The overview of today's webinar is to master the ability to share an understanding of what thermal energy is, how is it transferred from region of higher temperature to region of lower temperature. We'll also take a look at how we can apply the concepts of transfer of thermal energy to solve problems. We will also describe how energy transfer occurs in solid, liquids, and gases at the molecular level. In other words, we are talking about heat transfer via conduction. And we also describe convection in liquids and gases in terms of density changes. We will also attempt to explain how energy is transferred in the body by radiation, state the factors that affect the rate of energy transfer by radiation, and then describe how the concept of thermal energy transfer by conduction, convection, and radiation applies to everyday life. So let's take a look at basics of thermal energy. What is thermal energy? Thermal energy is also known as heat energy. It's the total amount of energy that all the particles in a substance have. The SI unit of thermal energy is given as joule. And when thermal energy is supplied to an object, the temperature of the object will increase. Something to take note about thermal energy is that it always flows from a region of higher temperature to a region of lower temperature. And there are three modes of energy transfer, and that is by conduction, convection, and radiation. So let's take a look at conduction first. Thermal energy is transferred in a medium via direct contact without the movement of the medium itself for conduction. And thermal energy is transferred through two possible ways. One is vibration of particles such as atoms or molecules. The second is the motion of free electrons. Conduction can take place in all three states, solids, liquid, and gases, where solids are better conductors in comparison to liquids and gases. Let's take a look at vibration of particles to better understand how heat is being transferred via vibrations. When we talk about solids, for example, the particles in solids have strong attractive forces between them, and they always vibrate about their positions. So when heat is supplied to one region of the particles, these particles will gain energy and vibrate even more. And these vibrations will pass along the particle to particle along from the heat source, and as a result, heat is conducted towards the end of the object in a single direction. Then in terms of vibration of molecules or particles, the particles and solids are close together, so therefore the vibrations can pass on easily from one place to the next. And the reason why the solids are good conductors of heat compared to liquids and gases, because the particles are packed much closer together in comparison to liquids and gases. Next, we look at motion of free electrons. Motion of free electrons only applies to metals because metals are the only ones that have free electrons, which are free to move throughout the metal. The free electrons carry thermal energy with them, and they move from the hotter region to the cooler region. And because of the movement of these free electrons, the transfer of thermal energy is sped up. So that explains why metals are good conductors of heat as compared to non-metals. Okay, reason being, metals have free electrons that helps to carry the energy faster along the path in comparison to metals which does not have these kind of free electrons. Next, we talk about applications of good conductors. Metals are used for making cooking pots and pans so the heat can be conducted easily to cook the foods. So this is one good example of using metals as a good conductor. Another application of a good conductor is a copper tip on a soldering iron. And what this does is that it helps to melt the solder faster because it's a good conductor of heat. The next kind of application of good conductors, heat sinks that are found in computers, TVs, and other electronic equipment will help to conduct the heat away faster. So this is another application of where we apply good conductors of heat. And then that doesn't mean poor conductors have no usage. We can also apply poor conductors in a number of situations, the most common of which is if we have plastic or wooden handles. These kind of materials are poor conductors of heat and they are used for the handles of cooking utensils, pots and pans so that we can actually hold on to a hot pot easily without burning ourselves. Then you have oven mittens that are used to take hot cakes or muffin trays and oven trays out from the oven, or we can actually use them to hold on to pots that are quite hot, or we can also use dry towels. These are examples of where we can apply co-conductors. And how is an oven mitten or dry towel co-conductor? Reason being, these kind of things have lots of empty spaces in the fibers that is found in the gloves. So these empty spaces are filled with air, and air is actually a poor conductor of heat. Some more examples of poor conductors: double glazed windows, also known as having two glass sheets with trapped air in between them, and cavity wall insulation, where we actually have polystyrene foam pumped in between two brick walls. These kind of designs are actually used to prevent heat loss from the house during winter, because during the winter weather, the house temperature inside the house is of a higher temperature compared to the exterior of the house, because there's heater in the house, but no one wants the house to cool down very quickly. So what they do is they actually have double glazed windows where you have air trapped in between and you have styrene foam in between the brick walls. All these things have air particles in them, and that will actually be a co-conductor to prevent heat from being conducted to the outside quickly. So these are applications of co-conductors. The next mode of heat transfer is convection. The definition of convection is a process by which thermal energy is transmitted from one place to another by the movement of heated particles of a gas or a liquid. Taking note that convection only takes place in liquids and gases because the particles in solids cannot move at all. And how convection is taking place is due to the change in density in different parts of a fluid. In this slide, we can see if you actually heat up a fluid, the heated particles will vibrate stronger and therefore it will occupy more space. So this heated fluid will expand and becomes less dense, and when the density is lesser, it will rise up while the cold fluid, which is denser, will actually sink, and this will actually set up a convection current. So this convection current actually helps the fluid to get heated evenly. So applications of convection in liquids, for example, we have boiling water, where the heating coil of the kettle is always at the bottom, and then when it's at the bottom and heats up, it sets up a convection current and causes the fluid or the water to boil completely in the kettle. Then we have hot water systems, where again we actually heat up the water from the bottom, which is cold water, and then the warmer liquid will actually rise up and be dispensed as hot water. So this is the hot water systems we have in the household. Then the same thing applies to cooling system in car radiators. So what happens is that we have water circulating in the car radiator system. So again, your hot water will actually rise up because it's less dense while it's being channeled through to cool down the engine, and the cool water will actually move downwards, causing a convection current to set up in the car radiator system. So through this current, convection current, the engine can be cooled down easily by the movement of the fluid in the piping. Then if we talk about convection in gases, one great example is heater. This kind of heater is not found in our country, but it can be found in other countries which have the winter season. Reason is they need to heat up the interior of the house. So how this heater works is, you heat up the air around it, and warm air, being less dense, will rise. The cooler air will actually sink down and be heated up, and this convection current is actually set up. And eventually, the whole room or the whole house will be warmed up efficiently. On the other hand, in our country, over here, we often use air conditioners. So if you notice carefully, air conditioners are always installed near the ceiling because our cool air, which is always denser, will always sink. The warmer air in the room will actually rise up because they're less dense, and it will be taken in by the air conditioner for cooling before the cool air is being expelled out. So this cycle will repeat itself, and this is the convection current that is being set up for air conditioner. So if you compare the air conditioner to the heater previously, heaters are always installed near the ground level, whereas for air conditioner is always installed near the ceiling. Okay, other applications of convection in gases, another good example would be the refrigerator, because the freezer compartment, which is in the above section, will have cool air flowing downwards because it's less dense, and then this cool air will actually channel through to the bottom compartment, and the warm air in the lower compartment will actually rise up and be cooled by the freezer compartment. So this will set up a convection current as well in the refrigerator to help in the efficient cooling in the interior of the fridge. And other natural situations when convection in gases takes place would be your sea breeze and a land breeze, where your sea breeze takes place in the day and your land breeze takes place at night. Okay, so if you look at this sea breeze, which is the diagram on the left, we can see that during a hot day, between the land and the sea, the land will actually heat up faster than the sea. So what happens is that the gases or the air above the land will be heated up, becomes less dense, and rises up. The cooler air from the sea will actually sink down and takes its place, and this whole thing will be set up as a convection current, and the wind or the air will actually move in from the sea. So that explains why it has a name called sea breeze. And the opposite is true at night, because at night the land will actually cool down much faster than the sea, and the convection current will work in the same manner but in the opposite way as the daytime. So that is known as land breeze. Further applications of convection in gases, one for example is ventilation. So if you look at these two diagrams over here, the first diagram on the left shows the modern kind of ventilation, where we have air conditioning units in some of the rooms, but in other places like the kitchen, we have warm gases rising up. So the whole idea is to allow the warm gases to rise up and be expelled from the house, while the cooler air actually sinks down into each and every individual room. So that's how the ventilation system would work. And if we look at the diagram on the right, this is how a traditional house looks like. Okay, in the past, in these kind of traditional houses that we find in villages, not every household have access to electricity. So we do not expect this house to have electric fans or air conditioners. So how do these kind of houses be kept cool during a hot day? So the way they build, if you notice carefully, at the top of the house, they actually have lots of gaps near the roof area, and that is meant for the hot air to actually rise up and escape from the house, and the cooler air will actually sink into the house so as to allow a better circulation of air within the room or the house. So that is how convection of gases takes place in ventilation systems. The kind of heat transfer that we are going to refer to is called radiation. So what exactly is radiation? Radiation is the transfer of thermal energy by electromagnetic waves. As we have seen earlier on, in conduction and convection, we require a medium to transfer thermal energy, but radiation does not require any medium at all. It can also take place in a vacuum. And then in radiation, the source of thermal energy transmit energy in the form of electromagnetic waves, which are also known as infrared radiation. And when these are absorbed, the energy of wave will transform into thermal energy of the receiving body. Okay, next thing to take note is that energy reaches Earth from the Sun by radiation. There is a vacuum between the Earth and the Sun, so therefore conduction and convection cannot take place from the Sun to the Earth. So the only form of thermal transfer, thermal energy transfer, is by radiation. Next, let's take a look at rate of energy transfer by radiation. There are three factors that affect the rate of energy transfer of radiation. The first of which is your surface temperature. The next is your surface area. So if you think about surface area, think about why elephants have large ears. Okay, next one is the color and texture of the surface. Okay, being shiny is actually a poor radiator, which we'll talk about it in greater detail later on. So let's talk about factor, which is surface temperature. The factor regarding surface temperature is that the higher the temperature of the surface of an object as compared to the surrounding temperature, the higher is the rate of infrared radiation from the object to surrounding. So one good example is the sun to earth. Sun's temperature on the surface is very great, so it is capable of transmitting infrared radiation to the earth quickly. The next fact area, the relationship of the surface area to the rate of infrared radiation is such that the larger the surface area of an object, the higher is the rate of infrared radiation from the object to the surrounding. So one good example is the elephant, another good example is the phoenix fox. Both of these animals live in an environment where temperature is very high. The phoenix fox live in the desert where it is very hot. The elephants live in the savannas where it is very hot and dry. So in order to cool themselves down, what they have is that they have huge ears. So having a large surface area, it allows the rate of infrared radiation to increase, therefore cooling down their body easily. The next factor for radiation is regarding the color and texture of the surface. When we have black, dark, and rough surface area, they are considered the best emitter, or sometimes we call them radiator and absorber of heat, but they are poor reflector of heat for black, dark, and rough surface. On the other hand, if we have white, shiny, and smooth surface, they are poor emitter or radiators and absorbers of heat but they are good reflectors of heat. So let's take a look at emitters of radiation in greater detail. So applications of good emitters. Dull black cooling fins that is found at the back of fridge are good emitters of radiation, where they emit the heat away quickly so as to channel the heat out from the interior of fridge to the outside environment. So you can see that all these wires are painted dull black because dull black is a good emitter of heat. Likewise for heat sinks, most of the heat sinks are always painted in the dull black color. Reason is dull black is a good radiator of heat and it will actually emit heat away quickly so as to cool down the equipment efficiently. However, poor emitters of heat has its own applications as well. So if we look at shiny metal teapots, there's a reason why these teapots are made as shiny because being shiny is a poor emitter of radiation that will allow us to keep the tea hot for a longer period of time. Another example of poor emitter of heat is your shiny aluminum foil. Shiny aluminum foil is a poor emitter of radiation, so what it does is it actually helps to keep the food warm before it is being served. And most of the time, this can be seen in catering of food. Either the containers that contain the food is a shiny container or they will actually have aluminum foil covering over the food before the food is being served. This is to make sure that the food is kept warm for as long as possible. Next, we take a look at examples of radiation. Applications of good absorbers. Remember, when we talk about good absorbers, they got to be black and dull. So if we look at solar panels, this is another good example. It is always painted dull black because dull black is a good absorber of radiation. This is to absorb as much radiation from the sun as possible. Next, we have dark colored clothes. Dark colored clothes are also good absorbers of radiation. It is not suitable for someone to be wearing dark colored clothes when they are supposed to be exposed to the sun for a long period, but is suitable for absorbing heat. Then for houses in hot countries, they are often painted white because white is actually a poor absorber of radiation. This is to make sure that the house interior is kept cool. Then we have solar control films. These kind of films are usually made from polyester layers, which is combined by specifically UV radiation absorbing dyes, and they are highly reflective metals. And since they are highly reflective, they are poor absorber of radiation. And since they are absorber of radiation, this will help to keep the infrared radiation out. Okay, so the picture over here shows how these films can be pasted on windows to help reflect the radiation away. So we have looked at all the three different modes of heat transfer: conduction, convection, radiation. Let's have a quick recap of the information that we have looked through. Thermal energy is also known as heat energy. Total amount of energy of all the particles of a substance is the thermal energy of it. The SI unit of thermal energy is given as joules. Thermal energy always flows from a region of higher temperature to a region of lower temperature. There are three modes of heat transfer, which is conduction, convection, and radiation. And in conduction, thermal energy is transferred in a medium via direct contact without the movement of the medium itself. Thermal energy is transferred through two ways. The first is vibration of gas, such as atoms or molecules, and if the material is a metal, There will be motion of free electrons that helps in conduction of heat. And conduction can take place in three states, mainly solid, liquids, and gases, where solids are the better conductors in comparison to liquid and gases. Then in convection is a process by which thermal energy is transmitted from one place to another by the movement of heated particles of a gas or liquid. And convection will only take place in gas and liquids because particles in solids cannot move about. Convection current is created due to a change in density in the different parts of the fluid. And in radiation is the transfer of thermal energy by electromagnetic waves. Radiation does not require a medium, it can actually take place through a vacuum. And the rate of energy transfer by radiation is affected by three factors. The first is the surface temperature of the object. The second is the surface area of the object. The third is the color and texture of the surface.